difference between positive, negative, and zero acceleration. Let us consider the motion of the same car. The velocity of the car increases for the first 6 seconds to 16 meters per second towards the right, then remains the same for 10 seconds and then reduces for 6 seconds until the car finally comes to rest. To calculate the acceleration for the 3 different time periods of motion, we choose a direction to be positive. Let us choose the same direction that we chose earlier as positive, that is, towards the right. We denote the 3 portions of motion of the car, that is, speeding up, uniform speed, and slowing down, as A, B, and C. Acceleration for the motion A. A bar equals delta V over delta T equals plus 16 minus 0, all over 5 equals plus 3,2 meter per second square, equals 3,2 meter per second square to the right. Acceleration for the motion B. A bar equals delta V over delta T equals plus 16 minus plus 16, all over 10 equals 0 meter per second square. Acceleration for the motion C. A bar equals delta V over delta T equals 0 minus plus 16, all over 6, equals negative 2,67 meter per second square, equals 2,67 meters per second square to the left. We see that the acceleration for motion A is positive, that for B is 0, and that for C is negative. Since acceleration is a vector, positive or negative acceleration depends on our choice of direction. It also depends on the direction of the change in velocity. For motion A, since the direction to the right is positive, the acceleration is positive, and the velocity of the car is also positive, directed to the right. The car is speeding up. For motion B, since the acceleration is 0, the car's velocity does not change. For motion C, since the direction to the right is positive, the acceleration is negative, and the velocity of the car is positive, directed to the right. The car is slowing down. Acceleration does not tell us in what direction the object is moving. Note carefully that in motion B, 0 acceleration only tells us that the velocity is constant. The velocity might be positive or negative. Similarly, in motion C, the acceleration does not give us the direction of motion of object, nor whether the object is speeding up or slowing down. We need the direction of velocity to determine the direction of motion. Here the car is slowing down, since acceleration is negative and velocity is positive. Slowing down is referred to as deceleration. It is an English word. Acceleration is a scientific word, and negative acceleration does not necessarily mean deceleration. We shall see this now. Let us continue with the same example. The car now travels in the opposite direction, starting from rest, and attains a velocity of 15 meters per second towards the left, in 10 seconds. Let us calculate the average acceleration. We denote this motion as d. Acceleration for the motion d. A bar equals delta v over delta t equals negative 15 minus 0, all over 10 equals negative 1,5 meter per second square, equals 1,5 meter per second square to the left. Now let us analyze this negative acceleration. The negative sign does not mean that the car is slowing down, for it cannot slow down from 0. Since the direction to the right is positive, the acceleration is negative, and the velocity of the car is also negative, directed to the left. The car is speeding up. Acceleration only tells us the direction of the change in velocity.
Starting to feel it? Now go master it with Maskitv.